The stoichiometry homework looks a little bit different. I'm trying something new within Canvas, so bear with me while we try something just a little bit new. Now, part of my question seems to have dropped off with the first question, but bear with me. So we have a chemical reaction. We have an amount of potassium permanganate. It will react in an excess of hydrochloric acid. The question is, how many grams of chlorine will be produced? Well, never assume that I've given you a balanced equation, and this one is definitely not balanced. The potassium and the manganese, they look okay. Now you can draw one of the charts like I presented in the previous topic with the balancing equations, but I'm going to give you a slightly different perspective with this one. So I see that my oxygen, I have 4 oxygens on the reactant side. So my gut reaction is to put a 4 here. That balances my oxygens. But that does change my hydrogen. So now I have 8 hydrogen over here, so I must need an 8 here. So now, what about chlorine? Now I have 8 chlorine on the reactant side, but on the product side, I have 5. If I was able to put a fraction here, I would put a 5 halves. And that 2 would cancel out with this 2, so I would have 5 chlorines here, plus 2, plus 1 more, then I have 8 chlorines on this side. But we know that our balanced equations must be our lowest whole number ratio. So I'm going to multiply everything through by 2, all of my coefficients. So I have 2 KMNO4 plus 16 HCl. That will react to form 2 KCl plus 2 MnCl2 plus 8 H2O plus 5 Cl2. So that is my balanced chemical equation. Now I have to answer the question. 49.3 grams of permanganate reacts in an excess of hydrochloric acid. So now I'm going to start with that 49.3. So 49.3 grams of KMNO4. And first I'm going to draw out the dimensional analysis and then we'll fill in the details. So I need grams of KMNO4 in the denominator, and I need to convert that into moles of KMNO4. Then I need to be able to convert my moles of, goodness, I can't write that, KMNO4 into moles of my product. This time it's Cl2 is what we're looking for. Then I convert those moles into grams. So now I can fill in my numbers. 1 mole of potassium permanganate. I look on the periodic table, I look up K, I look up Mn, and I look up O. I multiply O by 4, and I add all those together, and I get 158.03 grams per mole. Now I look at the stoichiometry of my balanced chemical equation. So I need a number here from my equation here. So the 5 goes there. Now I also need a number here. And this number is the coefficient in front of permanganate. So the 2 goes here. Now I can convert moles into grams of chlorine. I take the atomic mass of chlorine and I multiply it by 2 because chlorine is a diatomic element. It exists as 2 atoms joined together, and I get 70.906. And it's okay if your periodic table rounds a little bit and makes this 91, whatever. It'll all shake out in the end. It'll be fine. So then I do this arithmetic, and by do this arithmetic, I mean multiply across the top. 49.3 times 5 times 70.906. Then you're going to divide by, and if you're doing this all at once in your calculator, put in parentheses 158.03 times 2. And then you should end up with 55.3 grams of chlorine. So that is the answer that would go here. Number 2, the limiting reactant or limiting reagent of a reaction will always be a reactant and found on the left side of the equation arrow. That is true. Your limiting reagent will always be a reactant. So number 3, in this chemical equation, which compounds may be the limiting reagent or the limiting reactant? Well, it's not going to be water because water is on the product side. So I'm going to pick that up, drag that over to cannot be. NO is a reactant, so it can be, so is hydrogen, and then ammonia cannot be. And number 4, we have a big limiting reactant problem. Now this limiting reactant problem is involved, and you have 2 of these on your quiz, so make sure that you understand the steps. We're going to use this scenario and we're going to find all of the pertinent information. So I'm going to see if I can just copy and paste that here. Yes, I can. So let's look at this. If we start with this chemical equation, now again, never assume that your chemical equations are balanced. So I look at nitrogen. Nitrogen is balanced. My hydrogen is not. I have hydrogens in 2 different places on the product side, and my oxygen is balanced. So it looks like I have 5 hydrogens here. 5 halves would make that comfortable. I can't do 5 halves, so I can do a 2, a 5, a 2, and a 2. Now I'm balanced. So I'm going to start with my 70.8 grams of NO. And I'm going to find out how much product I can make. Which product am I going to aim for? The one I have a yield for. So I'm going to aim for ammonia. Now I'm going to set up my dimensional analysis first, and we can put in the numbers in a moment. So I convert my grams into moles. Then I'm going to convert my moles of reactant into moles of product. Then I'm going to convert my moles of product into grams of product. And I need to set that up for both of the reactants that are given. So 30.1 grams, and that is hydrogen. So again, I convert my grams of hydrogen to moles of hydrogen. Then I convert my moles of hydrogen into moles of ammonia. Ammonia is the product. Then I convert the moles of ammonia into grams of ammonia. So now we can fill in the numbers. Now we have the molar mass of nitrogen monoxide is 30.01. I went to the periodic table. I looked up nitrogen. It's about 14. I looked up oxygen. It's about 16. So 30.01 grams of NO is 1 mole of NO. Now I look to the balanced chemical equation. And the number that goes for moles of NO is this coefficient here. The number that goes for moles of ammonia is this coefficient here. So we need that balanced chemical equation. Now in this case, they both happen to be 2, so that's convenient. Then we need the molar mass of ammonia. The molar mass of ammonia is 17.03. Again, go to the periodic table, look up nitrogen, and add up 3 hydrogens to that. You should get about 17.03. And when you do this arithmetic, that is 70.8 times 2 times 17.03 divided by the product of 30.01 and 2. And you should get something along the lines of 40.177 grams of ammonia. Now, I did not use significant figures there on purpose. I'm not ready for that yet. Now, we run through the hydrogen. Again, we convert moles of hydrogen into grams of hydrogen. Hydrogen is diatomic, it's H2, so the formula mass for diatomic hydrogen is 2.02. We use the balanced chemical equation in order to convert our moles of hydrogen, which we have a 5 in front of hydrogen, into moles of ammonia. There's a 2 in front of ammonia. And then we use the same formula mass for ammonia there. And when I do that arithmetic, I get 101.506 grams of ammonia that are possible. Now that means our NO is limiting because we make less product with that reactant. Then our theoretical yield, we started with 3 sig figs for all of our measured quantities. Now our theoretical yield is 3 sig figs. We look next door, so that's going to be 40.2 grams of ammonia is my theoretical yield. Now we can find our percent yield. Now percent yield, we take our actual value given to us, divide it by the theoretical value, and multiply by 100. And I get a percent yield then of 92.3. I'm just going to show you how these go in before we do the last part. So this would be 2, 5, 2, and 2. The limiting reactant, oh, we have a drop down. Isn't that convenient? Would be NO. The theoretical yield is then 40.2. I typed 5. And the percent yield is 92.3. So now we're looking at the excess. So what is the excess here? If NO is our limiting reactant, then that means H2 is in excess. The question is, how much is left over? So let's find out how much this amount of NO would use. So if we start with our 70.8 grams of NO, what we're going to do is calculate how much hydrogen we used. So I convert my grams of NO into moles of NO. Then I convert my moles of NO into moles of H2. I then convert those moles of H2 into grams of H2, and I get a value of 11.9 grams of H2 were used in order to use up my 70.8 grams of NO. So now I take what I started with. I started with 30.1 grams of H2, but I only used 11.9 grams. So I have in excess, I have 18.2 grams left. So that number goes here, 18.2. The grams is already given to you. And then the excess reagent then is going to be hydrogen.